Hey everyone, welcome back. In this video, we're going to go back to the Y Delta Bank, and we showed a fault current reactor, how it works, and we actually put a fault in it. But we're going to do a real quick one on the Y Delta. This happens quite often in the field. We've grounded one of the transformers, X2, and that's where we're going to get a 12240 at. But the wing pots, somebody has forgotten to take one of the wing pots, one of the grounding straps off. They must come off. In a Delta, you can only have one ground. So for this situation, somebody accidentally left one on. We're going to show where the fault current occurs and how to quickly shut it down. So that being said, three-phase breaker's off. This is off. I have got my resistance dialed to the left. Max resistance. I'm going to go to my bank while everything is de-energized. Turn my breakers on. And another thing about it is when we check our banks, we don't want to test everybody's bank at the same time, because not that the fault current reactor can't handle it. It's like, well, we may have a fault on all three, but which one is it? We may have a fault on one. Which one is it? When you do them one at a time and bring them up, there's where you find your fault. From that point on, you can go into parallel in your banks, whatever you need to be. Because these secondaries right here, just to let you know on this, these secondaries separate the banks. And also to let you know, I didn't talk about this, these are 5 mil powder coated lines. So these are 120, 240, 277, 480. They're insulated for up to 600 volts, but wear your gloves. But again, I'll back this up. It's not really designed to be worked on while it's energized. You'll de-energize it, make your connections, and you'll re-energize back of your three-phase breaker box. Same way with your lines up here, all powder coated, 6 mil. It's supposed to be good to up to 600, but we don't treat it that way. We treat it as it's fully exposed. Again, we don't work on it while it's energized. So, with that being said, I've got my bank, I've got all the breakers closed in, and I'm going to go over here and I'm going to turn the bank on, energize it. A phase coming hot. 1/10 of an amp, 2/10, 1/10, 2/10, and C phase should balance it out. Now we're all back down to 1/10 of an amp. We notice our voltage drop down a little bit. The more banks you put on it, it'll drop down, but you can increase it. But for right now, we're going to throw a fault in the line. Somebody forgot to put the ground strap on. I'm going to do it while it's energized. But again, this is just for video purposes. I got my rubber gloves on. But I'm just going to show you quickly. Fault in. So where are we at? About 1.7, 0.8. Take the fault out. Fault back in. And we are on A phase where the fault is at. We're going to take the fault back off. But also watch your voltage drop way down too. It indicates you have a fault that we are feeding. Higher current, lower voltage. But again, the tool works great for that. With that being said, we're going to move on to the next bank.